Hi everyone, welcome to this lesson on dilutions. In the last section we learned about molarity or concentration. Remember, molarity is sort of a fancy term for concentration. And we learned how to calculate the concentration of a solution. Right? So I'll just take you back for a moment and remember that concentration or molarity is equal to moles over the volume. And we report concentration in terms of moles per liter. All right, so now in this section we're talking about diluting some type of solution in order to make it less concentrated. And I think that if you think about the types of dilutions that you're familiar with already, not necessarily ones in chemistry, but just in everyday life, one that pops into my mind, for example, is if you have a really strong cup of orange juice or a really strong cup of coffee or anything that you feel is a little bit too strong to drink, what can you do? Well, most of us would just add some water to it and it would not be as strong. Essentially, we just dilute it. And it's not any different when we're talking about chemistry and aqueous solutions. So essentially what we're doing when we perform a dilution is we are just making the volume greater so that the concentration is now less. And if you think about molarity or concentration and this formula that we use for it, C is equal to moles over the volume in liters, and you think about what's really happening when you do a dilution, it makes a lot of sense. So let's imagine that this is our cup of coffee or orange juice or whatever you like to drink, and you take a sip and it's way too strong. Okay, well, it has a certain concentration and we'll call it C1. Okay, it also has a certain volume and we'll call that V1. If we add some water to that solution or to that cup of orange juice or coffee, what we've done is we have made the volume bigger. We still have the same number of moles of orange juice or moles of coffee or caffeine or whatever you have, but we have a greater volume here. And if you look at the picture, if you counted all the little yellow dots, you can see that the moles haven't really changed. But now that we have a greater volume, and we'll call that new volume V2, we also have a new concentration because now we have the same number of moles in a larger volume, and so we'll call that C2. And this is essentially the meat and potatoes of a dilution. So we're going to learn a formula in this section on how to perform a dilution calculation, and it basically involves these four terms right here. So your initial concentration and your initial volume, and your final concentration, your final volume. And it's pretty simple. So let's go ahead and look at that formula. So all the dilution calculations that we're going to do in this whole section involve this simple equation. And it says C1 V1 equals C2 V2. Now, if you're using your Hebden textbook, you'll notice, if you have a look on page 102, that they have a slightly different formula. It's actually the same one, they just used a little different terminology. So they call it C concentrated instead of C1, V concentrated instead of V1, and then C dilute instead of C2, and V dilute. Now, if you like that one better, go ahead and use it. Students, I generally find students like C1 V1 equals C2 V2 better only because it's easy to remember. And the 2 obviously then means your final concentration and your final volume. But you can do whatever you want. So they're both options. We're going to use this formula here, and we're going to have to rearrange it in this section. And most of the time, well, not all the time, but in this particular lesson right now, we're going to be solving for the new concentration. So for C2, we're going to be given the initial concentration, initial volume. We're going to add some more water so that we have a new volume, and then we're going to solve for C2. And then in the next lesson, we'll look at solving for some of the other variables. So if I want to solve for C2 and have it all by itself on one side of this equation, I need to get rid of the V2 that is being multiplied by C2. So in order to do that, to rearrange this equation, if I divide both sides by V2, it's going to cancel on the right hand side, and I'm going to be left with C2 equals C1 times V1 over V2. You want to be comfortable rearranging this formula for yourself so that you can isolate C2 and solve for it. Let's go ahead and do a simple example of a type of question that involves this formula, and it's a dilution calculation. So here's our question. If 30 milliliters of 0.90 molar, okay, notice the units of molarity here, moles per liter or capital M, okay, they're both the same, 0.9 molar hydrofluoric acid, HF, is diluted to a total volume of 50 mils, what is the molar concentration of HBr in the resulting solution? All right, I wrote it like this on purpose because the textbook writes it like this. And instead of asking what is the new concentration, it sounds a little bit more complicated. What is the molar concentration of HBr in the resulting solution? So you can, for yourself, really identify what is it asking. It basically wants the final concentration. The first step in solving any of these questions in chemistry is making sure you understand them. And sometimes breaking it down into more simple terms is a really great way to do that. So if you don't like the way it's written, rewrite it for yourself. What am I looking for here? Final concentration. So we're going to use our formula. I recognize that this is a dilution. I can see that I'm starting with a certain volume of a certain concentration of hydrofluoric acid, and then I'm going to dilute it, and I even see the word dilution in here, to a final volume of 50 mils. So I know that this is a dilution, and I can go ahead and use that formula, C1 V1 equals C2 V2. Now the next step is identifying what I'm looking for, which is C2. It's the final concentration. And I'm going to rearrange this formula. Remember, we said we had to divide both sides by V2 if we want to get that C1 all by itself. So I'm going to go ahead and do that. So now I've got final concentration equals C1 V1 over V2. All right, I'm actually ready to go ahead and plug this in. Now, in case you're feeling a little bit lost at this point, I often recommend to students, when you have a question with a lot of information in it, you can go ahead and write right in your question, what is C1? What is V1? What is V2? Or sometimes you can draw yourself a little picture, and that's helpful as well. I'm just really quickly going to do both, so bear with me. So imagine I was a visual learner. I might draw myself a picture. So I'll say, okay, here's what I'm starting with. This is my original solution. So I've got 30 mils of it. Okay, well that's my initial volume. So V1 equals 30 mils. Okay, and I can see that the concentration is given to me. It's 0.9 moles per liter. So there's my C1. Okay, now when I do my dilution, I'm going to have a greater volume. So now my new volume is 50 mils. So there's my V2. Okay, and my concentration in the resulting solution is unknown. That's what I'm solving for. So this is a great way to break down your question and unpack it if you are a visual person. If you don't like to take the time to draw it, it's more time consuming. Another great way to do this is just to identify your different variables right in your question. So for example, the C1, the initial concentration, is this 0.9 right here. So I could go ahead and label that C1 right in my question. V1 is the 30 mils that I'm given. So I could just go ahead and identify that. The 50 mils is my final volume, so that's my V2. And the C2 is this one that I'm looking for over here. So this way I can pop them right into my question, and there's no chance of me making a mistake. All right, let's go ahead and solve this now. So I'm going to enter in my values. I'm looking for C2 here. Okay, it's equal to C1, which we said was 0.9 moles per liter. Keep your units in your calculations always. Multiplied by V1, which is 30 mils. Notice that I'm also keeping my sig figs in here. I'm not writing just 30, I'm writing 30.0. That's going to help me at the end when I have to figure out how many sig figs are in my answer. Final volume is 50 mils. So I'm dividing by 50 mils. And there's something you might notice here. I didn't have to convert from milliliters to liters. I just left both volumes in milliliters. Why did I do that? Because in the last section, molarity, I had to always make sure I was in liters. Well, the great thing about dilution calculations is that we have volume in two places here, okay? And so as long as my units are the same, it doesn't matter if they're milliliters or liters. As long as I'm consistent, I can't have one in liters and one in milliliters, but as long as they're the same, they're going to cancel, so it doesn't matter. So don't go to the extra effort of converting these volumes to liters. That is not a good use of your time. Notice what's going to happen right away here. My mils are canceling with my mils. My final units for my C2 are going to be moles per liter, which is exactly what I wanted. So I'm ready to go ahead and do this math, and let's see what do we get for it. Well, when I do the math, my answer comes out to be 0.54. And I'm going to be really careful here and look at my sig figs and also my units. My units need to be in capital M moles per liter. And before I go ahead and report this as my final answer, I just want to look at my sig figs. Remember, this is a multiplication division question, so my answer is limited to the least number of sig figs in my data, in the numbers that I used. So if I look back here, I've got 2 sig figs in C1. I've got 3 sig figs in the 30 mils, and I have 3 sig figs in the 50 mils. So the least number was 2 sig figs, and that's how many I'm allowed to have in my answer. 2 sig figs. So I've got 2 sig figs there, and that's my final answer. So C2 is equal to 0.54 moles per liter of HBr. Okay, let's go ahead and do another example. Here's our question. It looks really similar. If 30 mils of 0.90 molar hydrofluoric acid is diluted by adding 100 mils of water, what is the molar concentration of HBr in the resulting solution? Okay, so this question is pretty similar. I did this on purpose. So we can go ahead and start our C1, remembering our formula C1V1 equals C2V2. And we can go ahead and start to identify the C1, the V1, etc. So let's go do that. So first off, C1 is my initial concentration. So there it is. Okay, my V1 is my initial volume, so that was the 30 mils that I started with. And then it's tempting to go ahead right here and say that this is your V2, 100 mils, but be careful. When it comes to final volume, read these questions carefully. Be aware of whether the question says that the total volume is a certain amount, 100 mils for example, or whether a volume has been added. It's a really big difference here. If the total volume is 100 mils, then you're good to go. If it says that you added 100 mils, you need to take that into consideration. So here, it's 100 mils plus whatever you started with, so 30 mils. So this is a common error I see from students, so just be aware of what you're, read it carefully, and what is your final volume. So here, V2 is going to be 100 plus the 30 mils that there initially was in our container. Okay, so in total then we have 130.0. Remember your sig fig rules. Okay, decimal places here. 130 mils. Okay, so now I've got everything I need. I can go ahead and plug this in. I'm going to rearrange this formula. I want to solve for C2. So C2 is equal to C1V1 over V2. Okay, I'm going to start to work a little bit more quickly here. So I plug in my values. C1 was 0.90 moles per liter, keeping my units in my calculations. 30 mils was my initial volume. And again, no problem that I'm in milliliters because both my volumes are in milliliters. And now my final volume is 130 mils. And my milliliters cancel. I'm ready to go ahead and compute my final answer. So C2 is equal to 0.207. I'm going to leave some decimal places here, 69. Okay, give yourself enough that you're not going to round off too quickly, okay, before you start to think about your sig figs. My units are moles per liter. And now if I look back on my sig figs, I can see that I am allowed to have, again, 2 sig figs in my answer because this is a multiplication division question, so I am limited to the least number of sig figs in my data. So 2 sig figs will be right here, which means that I can round up that 0 to a 1 because the 7 is greater than 5. So C2 final concentration is 0.21 moles per liter. I've got my units in my answer and my sig figs. Okay, you remember your formula for dilution calculations, and you're going to go ahead and try some of these calculations on your own now. Best of luck.